Okay, so today what we're going to be doing is finding the pattern in signs and numbers to help factor and multiply expressions. So factor is a fancy way of saying break into its multiplication parts. So if I said, hey, what are the factors of 12? One of you would be like 1 times 12. And I'd say, okay, are there any others? And you'd say, oh, 2 times 6. Someone else would be like 3 times 4. So it's basically breaking it up into its multiplication parts. Okay. Think about Legos, like how you build like a Lego ship. And I'm building the Lego ship and I can break it down into its Lego pieces. So here it's just its multiplication pieces. Okay. So here it says use area model diagrams to multiply binomials with different signs, and then use area model diagrams to factor trinomials when some of the terms are negative. And what happens to the factors of a quadratic expression when some of the terms are negative? Okay. Does it change the way you think about it? Like, remember Nathan's question was what plus what gives me 12 and what, no, it was 13. What plus what gives me 13 and what times what gave me 12? Same question, except for now the 12 and the 13 may have maybe negative. Okay, so same thing. Okay, so we're doing this the whole context with Optimus quilts. And so now they're accepting orders for rectangular blocks. But sometimes they'll want one with standard length and the other one is 2 inches bigger. So I looked at some of your work and I agree with it. So this is X and this is X plus 2, exactly. So someone else wrote X and X plus 2, exactly. This person put X times X plus 2 and they came up with X squared plus 2X, exactly. So if you have this as your answer, perfect work. You and your group did great, right? X times X plus 2, perfect. Perfect. And for those of you who can do this without using the tiles, don't feel the need to draw your tiles. Don't feel the need. The tiles are there to help you when something doesn't make sense, because concrete things, drawings, will always make more sense than algebra, right? Because the algebra comes from our drawings, okay? So I see a bunch of, someone else drew it like this, see your X, and then here's their 2 X's. So X squared plus 2X, you can kind of see very tiny there. Very good. So this is all great, showing great understanding. Someone else drew it all out. Very good, very good. Okay, so if you wrote one of these, awesome work, perfect. Okay. Not even gonna show you over here because your work is so well done here. Okay, this next one says, so sometimes they want blocks with one side that's the standard length, so X, and another side that's 2 inches less. And we had talked about, what does 2 inches less mean? Oh, that's just X minus 2, right? X minus 2. So let's take a look at what you guys did. So wait, hold on a second. Did I read that wrong? So one side is X and the other one is X minus 2. One side is X and the other side is X minus 2. So let's look at what some of your classmates did. Yeah, here you got X and then -2. They even put little negatives in there. Fantastic. They even colored it red. I don't know if you guys know this or familiar, but in the financial world, when they say things like, oh, you're in the red, that means you're in the negative one, like you owe people money, right? So whoever colored this red, good job. You don't have to color things red. You don't even have to use the tiles. But both of these answers are perfect right here. You even followed their directions to write 2 expressions. So here's one, here's the other. This is as a product, and this is as a sum of terms. Perfect work here. Awesome. This is exactly what I'm looking for. So on a quiz or whatever, if this person shows this work for this kind of problem, do you see how like they showed all their understanding? Ms. Johnson, but you always ask us to explain. Doesn't this work kind of explain it? Doesn't that work kind of explain it? Exactly. Okay, good. Let's see, what else do we have here? Someone wrote this one. So here I don't agree with you because one of the lengths is X, right? Not X minus 1. So this one here, whoever this is, good job on the X minus 2. You got a little confused and you started subtracting 1 from too many sides, if that makes sense. So go back and fix this. I'm glad you made that mistake here. That looks good, really good, really good. Person who did this, and this is just the observation that I've made from doing this for years and years. Whenever I put a minus here, sometimes my students forget that this 2 is a negative. So I tend to put my minus here and change and make this like a plus. So x plus -2. So just so that you don't forget, because I want you guys to not get wrong answers. So yeah, x squared minus 2x and x times the quantity of x minus 2. Perfect answers. Okay. So here is where we got a little bit like, so many words. Okay. So this is where I'm going to pull over here as well. So there are so many other size blocks with the side lengths all based on the standard length x. Draw and label each of the following blocks. Use the diagram to write 2 equivalent expressions for the area. Verify algebraically the expressions that are equal. So one side is 1 inch less and the other side is 2 inches more. 1 inch less and 2 inches more. Wait, what? So let's look at what your classmates did. 1 inch less and 2 inches more. This is exactly right. Let's see if they multiplied correctly. And they're using this box method. This is good. X times x is x squared. 2x, -2. So x squared plus 2x minus x minus 2. They just forgot their little x here. No, not a big deal because they got the right answer here. So yeah, this looks beautiful. That looks good. So the first answer should look like this. X minus 1, x plus 2, x squared plus x minus 2. So that's, it looks like a lot of you got that. X minus 1, x plus 2, x minus 1, x plus 2, x minus 1, x plus, man, you guys are doing so well on this. I'm so impressed. Cannot wait to give you a quiz because you're going to show off all this great understanding, right? Okay, the next one says one side is 2 inches less and one than the standard, and the other side is 3 inches more. 2 inches less and 3 inches more. 2 inches less and 3 inches more. Yeah, so someone said x minus 2 and x plus 3. That's perfect. This one is x minus 2, x plus this, whoever this is, you're, I know the space here is not the best. So I think if you just draw like an orange line that says this is number 3 and this is number 4, then it's a little bit more clear. Very good. But yeah, you guys did fantastic. X plus 3, x minus 2. Good job. Very good job. And okay, so I have no complaints on this. So actual answer, I think this one got cut off a little bit. Is it because my screen is? Yep. So x plus 3 times x minus 2, right? And then x squared. Oh, this person, you just forgot your x. Don't forget your x. Because these are x's. Remember, these are like the sticks, right? So x squared plus x minus 6. Perfect. Perfect, perfect. All right, let's try to get to the last little one. So the last little one, they're saying, okay, so it's just more of the same. Okay, so what I want you to do is practice these, and then we'll come back and make sure that you understand how to do those.